Hello students, so today we are going to discuss about baryons. Baryons are, you can call baryons as, they're basically a group of elementary particles, and they can be called strongly interacting fermions. And when we say fermions, we mean that they have got half ventricle spins, and these baryons have mass which is either equal to or greater than the nucleon mass. By nucleon we mean neutron and proton. And there are three types of interactions, and that is valid in baryons. So those interactions are strong interactions, weak interactions, and electromagnetic interactions. So these interactions are valid in the case of baryons. And apart from, so baryons are actually made up of two different type of particles. First, as we say, they are made up of nucleons, as we have already mentioned. Apart from nucleons, baryons are also consist of a group of particles called hyperons. Now there are different types of hyperons. We have a hyperon called omega hyperon. We have a hyperon called cascade hyperon. We have one called sigma hyperon. We have one called lambda hyperon. And apart from that, we have the nucleons as well, as you have already told. So these are the hyperons. So hyperon and nucleon, they form the baryons, and baryons are also identified by a number called a baryon number, B. Now B is equal to 1 for a baryon, and it is equal to -1 for an antibaryon, and it is equal to 0 for others. So this baryon number is important. Now Similar to baryons, there is another classification of the subatomic particle called mesons. And these are, unlike baryons, they are strongly interacting bosons. So when we say boson, it means that they have got spin 0. And their mass is intermediate between lepton and nucleons. By leptons we mean electron, muon and tauon, electron neutrino, muon neutrino and tauon neutrino. So it is in between these two, and by these are the nucleons. So the meson mass is in between these two type of masses. It is more than the leptons and less than the nucleons, and they are also subject to three type of interactions. That is strong interaction, weak interaction, and electromagnetic interaction. Now the different type of mesons are as follows. This is called an eta meson, given as eta to the power 0, no charge. We've got K mesons, given as K plus, K minus, K0 bar. We've got pi meson, pi plus, pi minus, and pi 0. So this was about mesons. So next is your leptons. As we have said, it consists of electron. When it is electron, so it also will have electron and positron. It will have muons, and will have tauons, and corresponding to this you will have neutrinos, muon neutrino, electron neutrino, muon neutrino, and also tauon neutrino. And based upon this, it will have an antineutrinos as well. So these are the leptons. They carry a relatively conserved internal counter number called lepton number. L, and L is equal to 1 for leptons, like what do you say? L is for electron, muon, electron neutrino, muon neutrino, and then L is equal to -1 for the anti-leptons, that is citron plus and as in the case of baryons, L is equal to 0 for others. all about leptons. And now another important aspect in elementary particles or nuclear physics for that matter is a term called isospin, given by I and with this component I3. Now the basic or the fundamental behind isospin is that most of the particles can exist in three basic states. So it can be either positive, or it can be either negative, or it can be neutral. These are the particle can exist in either of these three states. So these are analogous to the same chemical, analogous to the grouping of elements having the same chemical properties with different number of neutrons in the nuclei. And the quantum states of these particles could be described by an appropriate quantum number, which on account of its over similarity to the spin of the quantum numbers S and Mx is called the isospin number. So as we have in the case of atoms, we have the spin quantum number and magnetic component of the spin quantum number in magnetic field. Similarly, in case of isospin, we have I and I3, which is analogous to S and Ms. And this was proposed by Wigner. And it can be called an isospin or isobar spin, whatever. Now there are different classifications of the elementary particles based upon the isospin, like in the case of nucleons, that means neutron and protons, they are called an isospin doublet. So we are basically talking about baryons now. So as told, baryons consist of nucleons as well as hyperons. In the case of hyperon, lambda, this is a singlet, and sigma is a triplet. When existing sigma plus, sigma minus, and sigma C2 is a triplet. Cascade is again a doublet, and omega is again a singlet. So again, in the case of mesons, the pi mesons, they form a triplet, and the k mesons, they form two different doublets, whether it's k plus, k minus, or k0, k0 bar. They are also from doublets. And lastly, we have got eta meson, which is again a singlet. Now, with these multiplets, the masses differ, but only slightly compared with the mass difference between the various multiplet groups. Now, a zero spin, as we can say, it can exist in another orientation state. So, the spin is equal to, say, half, or it can rather be as MSs can be rather have plus half or minus half, different upon the motion of the spin. So this consists of plus half, and if it is in this direction, magnetic moment, this is minus half. So similarly, we can have the multiplicity as 2s plus 1. So if s is equal to 0, it means a singlet. S is equal to 1 by 2, it means a doublet. This is equal to 1, it means triplet. So similar to this, we can have an isospin, that is 2I3 plus 1, the 2I plus 1. So I is equal to 0, I is equal to 1 by 2, and I is equal to 1. They form the different singlet, doublet, and triplet states.